Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
You would think, with all the conversations I've had with Brian Leakey, he would eventually start to understand how wrong he is about certain things. But it seems as though with him, it is the total opposite. From claiming the 24-hour sunlight in Antarctica doesn't exist.
The guy who did the 24-hour Antarctic sun, the ones you see on the internet, it's all that shit's coming from one dude, and we done fucking debunked his shit pretty thoroughly, man.
To claiming that all Southern Hemisphere flights actually fly north above the equator first, then back south to their destination. To claiming long-distance observations prove flat Earth.
So with all these Globers demonstrations, they're just helping prove a flat Earth.
To misunderstanding the solar analemma. To not being able to properly draw triangles on spheres.
Here's what happens if we do 3 60-degree turns on a globe. I covered the entire tropics. 60 degrees, 60 degrees, 60 degrees. Okay? Put the protractor to it.
To thinking that Puerto Rico is just a few miles off the coast of South Carolina.
And you asked Jose if he was in the tropics because Puerto Rico seems like a tropical climate, but I think it's off the coast of South Carolina. So it's not in the tropics. I don't believe.
Puerto Rico?
What?
Yeah,
Yeah,
please
Puerto
tell
Rico.
me you were joking. Just no.
I mean, that's what I just seen on the map. Puerto Rico is like about a few hundred miles off the coast of South Carolina, right?
Nah. I would have used Florida or something.
There's no shortage of claims that Brian will make and be completely wrong about, be corrected, sometimes even acknowledge that he may be wrong, and then come back the next day and make the same claim again. In one of Brian's recent Nobel Prize-worthy offerings, he demonstrates just how little he knows about refraction. First, he presents a few clips showing sugar water and fish tank demonstrations. These are always good because they show how a dramatic change in density will have a significant effect on the amount of refraction you see. The problem is, Brian believes that some of the bottom of the buildings are obstructed when they're actually just compressed, which is pretty obvious due to the amount of refraction created by the density gradient in the water, which is exactly what we would expect to see. I'm not sure how many times we have to repeat that light bends towards a denser medium. This is pretty evident the moment you Google, which way does light
You heard him
bend?
plain as day. We should see more of the city skyline because he's used sugar water to induce a gradient that they claim matches our atmosphere with the light bending downward toward the denser medium. But when they do that, just the opposite happens. Look at the city skyline. Look at the bottom. We see less of the city. So with line of sight over a flat surface, we see less of the city, even if light's behaving the way they claim. And that's causing the bottom of the city to disappear. Whatever it is, compression, or it's still missing visually.
Then Brian moves to a video by Bob the Science Guy, who's presenting an observation done by me using my auto level. My guess is Brian is trying to make some sort of connection between the refraction in the fish tank and my observation. Maybe he thinks the fish tanks and my observations have the same level of refraction. Or maybe he thinks I don't know how to set up an auto level.
And the bottom picture, now our crosshairs are halfway up the city skyline. So that's why we don't do long distances. Now here's B-Ball's setup.
Jesus Christ, Brian. If you're going to try and debunk me, at least use a higher quality image. Let me help you out there real quick, Chief. There we go. That's better.
So it looks like he's looking down. So it looks like his auto levels are probably set up at about 4 foot. And we'll say he's a few foot up the beach. So we'll give him about 7 or 8 feet of height. Now look at these windsurfers. Look, he's going up a wave. They're out on waves, probably about half a mile away. And so the crosshairs should be lined up with the top of his head. But it's not. The crosshairs are like above the sail of the windsurfer, which is about 15 feet. So I don't think he's got this thing set up right. But even if he does, refraction shows you what happens over long distances. But I'm going to show a demonstration of how setting up the instrument is critical. Okay, so I got one of my instruments, and to show you, you see how high it was, and to show you that the bubble is centered.
I know. Putting it on a tripod, turning those knobs, and getting that bubble in the center of the circle was super difficult. So difficult that even you had trouble getting it in the center. Listen, Brian, you might want to check your own setup first before you try and criticize mine.
So with all these Glober's demonstrations, they're just helping prove
Jesus Christ, Brian. Did you screen record this in 144p, then transfer it to VHS? Oh, my goodness.
a flat Earth, and they don't even realize it. So the top picture shows with an induced gradient us missing the bottom of the city, and it happens progressively over distance.
Well, Brian, if there's some kind of refraction that produces no mirage, no visible effects in the image, and only affects the level of the water and not the object in the background, we would love to see you reproduce this effect and tell us all what conditions need to be present in order for this effect to occur.
And look at the bottom picture with the windsurfers. Even if I give them a distance of a mile, that's 8 inches of drop. So if he's up on a 5 or 6 foot wave, the crosshairs should line up with his feet. But even if he isn't, the crosshairs at the very least should line up with the top of his head.
I don't know, Brian. Why are the crosshairs above the windsurfers? That's a great question. Maybe I angled my auto level up ever so slightly. Well, judging by the position of this bubble, no, that can't be it. Maybe it's optical drop, like your counterparts Brian's logic and Flatzoid claim. Nah, that's definitely not a thing. Think about this for a second, Brian. If I'm at 11 feet above the water, and my tool is clearly leveled correctly, there's no visible mirages, which means very minimal refraction, and I can see in the distance buildings of known height, and the horizontal plane created by the auto level is intersecting well above my local elevation, the top of a 15-story building, and I know the building is not at a lower elevation. What else could be going on? The tides, which in this location in Oahu, only change by an average of 2 feet on any given day throughout the year. Shoaling? Well, that only accounts for about 2 or 3 feet of additional wave height. Brian, if you look closely, the level of the water is in line with about the 8th floor in this building. That's about 80 feet of the building hidden by the water, which is almost exactly what's predicted by the Earth Curve calculator. And don't you remember having this conversation before, when you asked me to go to the same location later on in the day, which I did, and you claimed that I would be able to see more of the building, which I couldn't? Then after asking me to go to the same location at a later time in the day, you turned around and said it was the wrong time of the day? And then your best rebuttal was to call me a liar in a video? It seems to me that Brian, as well as most flat earthers, don't really care about evidence at this point. It's more like, as long as they can cast any doubt upon what's being presented as evidence, no matter how damning that evidence is, they can continue to hold that position that somehow the experts calculated or measured something incorrectly, without providing evidence of how incorrect it is. Can you say intellectually dishonest?
On the 5th or 6th or even higher floor, this is something that you can measure.
The process of leveling has not changed in well over 150 years. It is still a terrestrial measurement system that has limited sight differential. And particularly in geodetic leveling, about the farthest you can go is going to be about 50 meters. So you can't make observations 100 meters or 200 or 300 meters.
So you heard the professional say that the longest you can go is about 50 meters. Me personally, I don't like to go much over 50 feet, but 50 meters, he said you can't go 200 or 300 meters, but Bob thinks you can go 12 miles.
Now, Brian, you wouldn't be trying to cherry pick now, would you? Let's just see what else that professional had to say.
20s or 30s, here you see the pictures of the coast surveyors out with the old optical level, actually a Fisher level, and you've got 2 rodmen out. Well, the same process is true today, although increasingly we're seeing the use of digital leveling so that the observer themselves do not have to read the rods. The instrument is reading the rod. And so let's look at this one over here. Surveyor would go out, you'd have 3 surveyors. They would measure the angles of this triangle, and realizing that a triangle, the angles of a triangle have to amount to 180 degrees. Mind you, there's curvature of the earth, and so we're really dealing with with slightly different math, but let's just, you know, take it as simple as possible for the moment. If I know these angles, then I know the three angles of the triangle. But these are long distances. They might be 10, 15, 20, in some areas, 40, 50, 60, 80, 100 miles. How am I going to measure that? I need to have at least one distance that I know. So before the advent of GPS, they would take a lot of time to actually measure the distance between two of those points. It's referred to as a baseline. Today in GPS GNSS, we refer to as a baseline as the vector between 2 points. Well, this is very similar. It's the measured distance between 2 points. So they would go out and they would measure a distance here, and then somewhere else in this network they would have another measurement. And if I know this distance and I know the angles, I can then, through the law of sines, I can compute the distances along these other lines, and so on, and so on, and so on. And if I happen to know the coordinates of this point, and its orientation, or its azimuth, and I now know the angular difference to this point, and the distance, I can now compute the coordinates of that point.
And lastly, Brian is trying to claim that geodetic surveyors haven't measured spherical excess because the observations were line of sight. Oh, Brian, when will you ever learn? What you're missing here is that the distance measured is not a chord through the sky. It's measured along the surface of the earth. When this team of surveyors measured distances in 1916, it was done using a long metal tape, which is laid along the ground, not pulled taut between two control points, which is what you're suggesting here. I know you really and truly want the earth to be flat, but strawmanning the actual process of measuring spherical excess isn't gonna help. Once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video, and please check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.